Right. In the previous class we learned about OSI layer. Now we are going straight to layer 4. We have something to learn in layer 4. Layer 4, we call it as transport layer. Now what do we have in this layer? The function that makes the transportation easy. Like I said in the previous class, according to the capacity of the medium, the size of the data need to be segmented. Like we used to do now when we are having heavy load, cannot carry, we used to share with our family members so that all can carry and load will be balanced. Transport layer does the segmentation, that's why our data gets a name called segments. Now while segmenting, it will also do sequencing. If this is a big data and transport layer does the segmentation, it does the segmentation. Now this need to be sequenced. It needs to be sequenced. Why? Because these segments, when it goes to destination, on the way it takes multiple paths, not the same path. Sometimes the destination will receive the segment 3 first, and then 5, and then 2, and then 4, and then 1. Now because it is sequenced, it is numbered. Because the segments are numbered, the receiving device can rearrange it. It can rearrange and get the complete data without mixed, shuffled. So segmentation with sequencing is done in this transport layer. Each segment gets a unique number, and it helps to rearrange on the receiving end. Internet is a very big network with many paths to reach a destination. So there are chances that these segments, the small pieces, will take different path. When it goes in different path, sometimes the third packet goes first. As I showed earlier, they don't go in order. We need to rearrange it in order. For that it need to have sequence. So this is sequence number. Transport layer also deals with another number, that is port number. Source port number, destination port number, port numbers. So transport layer also deals with port numbers. We should not get confused with the sequence number and the port number. Sequence number is to rearrange it on the receiving side. The segments go in a mixed, disordered, not in a sequential way. So to rearrange it, we need number, so we need sequence number. Now what is this port number, why it is used for? Port numbers are to identify session. We also have session ID in the session layer, but this is to identify to which session this belongs to. More importantly, the port numbers are to identify the service. What does that service mean? We have various network services. HTTP is an example. TFTP, another example. SSH, FTP, Telnet, SNMP. These are all examples for services. If this computer here is talking to this computer here, if A and B are talking, there are different type of topics to talk. What topic A wants to talk to B? A can talk Telnet to B. A may also want FTP with B. B can support all this. If someone is asking Telnet, it will support Telnet. If someone is asking HTTP, it will support HTTP. B is a server which can do all this. So now A should tell B what exactly it is looking for. See, someone can come and ask you water. They may also ask you food. They may also ask you to teach OSI layer. They may also ask you to give your bike for 5 minutes. They may ask you for a help, maybe a road crossing. See, you can do a lot of things. If someone simply comes and stand next to you, can you help him? No. He has to open his mouth and say why he has come to you. If he comes next to you and say, I want water, then you can give water. That is what port number is used for. Asking water, asking food, asking for a ride. In networking, each network job is identified with a number. That number is what called as port number. As I said, Telnet is one job, identified with the number 23. SSH is another job. What is the reserved port number for SSH? 22. Like this, we have various jobs. And each job is identified by a number. That number is port number. Number between 1 to 1023, they are reserved port numbers. They are reserved for various services. They are reserved port numbers. They are reserved for various services. Port number 1024265535. These are not reserved, not registered. These ranges can be used in various games, applications like games. When you develop a software, for your software to interact with its client, you can reserve. You can take it and use it. So the port numbers are basically to identify a network service. For example, A is telnetting to B. In that case, A is the initiator, right? So A will use some random port number which is not reserved. Let's say 5555. Randomly it will pick one number. But the destination port number is going to be 23. Why? Because it wants to have telnet session with B. So when this packet goes to B reads the transport layer, finds that A wants telnet session. How B knows that? Because B knows if it is 23, it is telnet. This is how the devices identifies the service that you are expecting. If I tell in English language, it will not know. But when I put port number 23, it knows that I am looking for telnet. So, port numbers are to identify the service. The sender will always use a random port number. So A is telnetting to B with a destination port number 23, but source port number can be any number greater than 1024. Between any number 1024 to 65535. Next, when B responds, when B is responding to the telnet, this port number will become opposite. What does it mean? Because B is responding with telnet, so that becomes source, and it is responding to A 5555. So when any packet comes to this port number A, it knows that it's a reply for the telnet session. So it helps to identify that this packet is for telnet session, because earlier A only was sourcing with 5555. So when response comes to 5555, A knows that it is the response for the telnet which I initiated. This is how the port number is used in transport layer. So far we have seen three things: segmenting, sequencing, source and destination port number. Next, Transport layer is also responsible for communication. This communication is of two types. One is TCP based communication, the other one is UDP based. See, these both are important. Both are important. It's not like one is lower than the other. Let's say you have a bike which you bought 1 year before. Not 2 years, I said 1 year before. You might have bought 2 years before, but I don't want to say 2 years before. 1 year before. And this year you are buying a car. Now will you throw that bike outside the gate? No. You need both. Whenever you are going alone, not with the family, you will be comfortable to go with bike. Like me, I don't like really driving the jeep. But when family comes, I have no other option, I take the jeep. But most of the time I go in my scooter. Both are important. When I go alone, scooter is important. When I go with family, jeep is important. Likewise. TCP is also important, UDP is also important. I am telling it very seriously. That's why I am making this story and all. You should not forget these things. Sometimes we imagine that this is better than that, so we don't need that. Sometimes some people also will teach you like that. Those are all not the right version. Both are important. Bike is also important, car is also important. If you consider TCP as a car and UDP as a bike, or the other way, both are important, right? TCP is connection oriented. TCP is connection oriented. UDP is best effort delivery. What does that mean? TCP demands acknowledgement. UDP no, doesn't. TCP, because it is demanding acknowledgement, this is reliable. This is not unreliable. Because it is unreliable, you cannot say UDP is bad. That is what I want to say. Going in car is safe than going in a bike. Does that mean that bike is bad? No. Going in car, you won't fall. When you go in bike, there are chances that you will fall. Going in car, makes you feel that it is reliable, safe. But still we use bike. Likewise, UDP, though it is not a connection oriented, though it is unreliable, what does that mean? There is no guarantee of delivery. If a packet is sent using UDP, there is no guarantee. In TCP, acknowledgement will come. If acknowledgement is not coming, then the same copy will be resent again till it gets the acknowledgement. So it is reliable. When you get the acknowledgement, you are 100% sure that this packet has been delivered. That's not the case with UDP. No acknowledgement. So you are not sure whether it is delivered or not. Maybe, may not be also. But still UDP is important. Same like TCP. How? Where? Today our network needs fast communication, fast recovery, fast communication. If there is an attack to a network, we want a firewall which can identify the attack and mitigate it very fast. If firewall is very slow, attack is already happening, and firewall is coming after a few seconds and saying attack is happening, I am going to stop. No, that is not good. Before we realize that there is an attack, firewall should have stopped it. Convergence. If a path fails, we don't want disconnection. We want another path to be taken as soon as possible. For these things, UDP is important. Fast, best effort delivery. They don't wait for acknowledgement. They don't spend time waiting. They quick send it. So wherever there is a need for discovery of a path, discovery of a neighbor, fast conversation, fast communication. Example, this call that we are having now, online class, this all demands fast communication. So this all uses UDP. Let me show you that. So all the streaming traffic uses UDP. All streaming traffic. So UDP, if we don't have, we can't have this class. Why? Because TCP is slow. TCP is slow, UDP is fast. Why is TCP slow? Because TCP, before sending next packet, it waits for the acknowledgement of the previous packet. It needs acknowledgement. For every single packet that is sent, it needs acknowledgement. So it is slow. UDP is best effort delivery. No acknowledgement expected. So it just streams. It sends hoping that it will be delivered. But TCP will not hope and all. It wants to have a confirmation. Not only that, TCP will stop the conversation in the middle and check whether we are connected, connection oriented. After confirming that we are connected, then it will continue the transfer of data. So TCP every now and then will check for the connectivity. We call that as three-way handshake. Three-way handshake. TCP does three-way handshake. That is why we call it as connection oriented. UDP is best effort delivery. No three-way handshake at all. What is this three-way handshake? Let's say this computer wants to telnet to this computer. A wants to telnet to B. Before sending the telnet packet, A will send one packet with a port number 23, destination port number, source port number random. This is not telnet traffic, this is called a SYN packet, synchronization packet. This is just to check whether B is available to provide telnet service. So it will send with a sequence number, let's say 100. And this is SYN packet, synchronization packet. When this is received by B, B will send acknowledgement, and B also want to communicate to A, so B is sending SYN-ACK. So B is sending its SYN packet along with the acknowledgement. When this comes, A will find the acknowledgement. What is the acknowledgement says? 101. What does that mean to A? It means that B has received 100 which I sent. I sent 100. He received, that is why he is saying what? 101. A forward acknowledgement. So A now knows that B is ready to respond, and A is also finding a SYN packet of B. For that it will send acknowledgement. Finish. FIN acknowledgement meaning I got your packet, man. Now I am sending you the acknowledgement, which means I can see you, I can talk to you, you can also talk to me. So three-way handshake finished. See, I am sending you the acknowledgement. See, these three handshake is not the original data. It is just to make sure that both are able to support telnet. After this only the original telnet traffic will go. See, this is going to take time. That is why TCP is slow. But it is connection oriented. It establishes this connection. It's connection oriented. You understood? Three-way handshake. I'm sorry, I lost you. Your voice is not audible. But We need to understand that this happens not only the beginning, every now and then, frequently. Every now and then this is going to happen. A and B are talking, in the middle it will stop. It will do this three-way handshake. Then it will continue. So this cannot be used in voice, online, video call, conference, audio conference, WhatsApp, Facebook, Messenger. Cannot use these things. Why? They are instant messengers. They are streaming. They are time sensitive. See, TCP and UDP both are good. TCP is good wherever time is not a matter, reliability is a matter. UDP is good wherever time matters more than reliability. Alright, so we have seen transport layer. About the network layer, data link layer, what we need to know is network layer is responsible for providing source and destination IP address, and data link layer is responsible for MAC address. We are going to see the whole training, all IP address related and MAC address related. So we have come to the end of OSI layer. The sending device encapsulates the data with the 7 layer so that the receiving device will decapsulate and understand whether this packet belongs to B. When the MAC address of the B matches with the packet destination MAC address, it knows that it belongs to me. Likewise, when the destination IP address of the incoming packet matches, it knows that it belongs to B, and the port number and the session ID. And the presentation layer says how to handle this packet, and using the application it opens. So sender sends what type of packet it is, to whom it is, how it need to be treated. Receiver understands those things and uses the packet. So sender is sending by encapsulating, receiver decapsulate. All the 7 layer should be there for a valid packet. All 7 layer is needed for a valid packet. Right. So we'll stop.